Another type of equation that you might have to solve would involve higher degrees. So in this case, if you had something that involved a power, you would want to solve like you would something with a power. So what if you had some quadratic? You think about this as if sine was just a variable. Let's call it u. If we had 2u squared plus 7u minus 4 equals 0, how would you solve that? You solve this the same way, but then it winds up being that sine is your u. So if I was to factor this, I would multiply the 2 times the negative 4 to get negative 8 and write the 7 in the bottom. And I think about what multiplies a negative 8 that adds to 7. That's going to be a negative 1 and a positive 8. And then I'd factor by grouping, plus 8u minus 1u minus 4 equals 0. And then I have 2u minus 1 equals u plus 4. I don't like to factor by guess and check. I like to use this method. If you are unsure how to use this method, I have a video on factoring. You're more than welcome to view that shows how to do this. That's going to be equal to 0 using the zero product property. I can then solve each of these equal to 0. But u is sine of x. So this is saying that the 2 sine of x minus 1 equals 0 and sine of x plus 4 equals 0. You then isolate the trigonometric function and you solve for that in the general solution. So 2 sine of x equals 1. So sine of x equals 1/2. Where does that happen at the unit circle? And here the sine of x equals negative 4. Where does that happen on the unit circle? It doesn't. Remember, sine without an amplitude change, it's not going to be less than negative 1. It's not going to be greater than 1. But sine equal to 1/2, y equals 1/2 at pi over 6 and 5 pi over 6. So we have pi over 6 and 5 pi over 6 if we're talking about on the interval from 0 to 2 pi, or pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi if we're talking about a general solution. Another way that you can solve trigonometric equations is by using identities. If you have something that you could rewrite, let's say you have a cosine of some larger value, you could use the sum to product formula, you could use the product to sum formula, you could use the Pythagorean identities, you could use the quotient identities, you could use any of the different identities to solve. It really involves you analyzing the information that you're given and determining which one would be most beneficial to help you solve. When you have an equation that's in terms of just sine and cosine, and you don't want to use a reciprocal or quotient, you might want to square both sides so that you can use the Pythagorean identity of sine squared x plus cosine squared x equals 1. That might help you. So that's something to consider as well. But you do have to check for extraneous solutions when that happens, because you're squaring something that means that you might add in some value that doesn't actually work or isn't actually true. The last thing you might need to do to solve trigonometric equations would be to use inverse functions. If the value does not fall on the unit circle, then we're going to need to use inverse functions to solve using our calculator and converting either to radians or degrees. Let's say I had the tangent of x equals 4. Remember that tangent is not going to be 4, unless your amplitude is different, but the typical values for tangent are 1 and negative 1, or root 3, or root 3 over 3. Your typical values are not at 4. And so in order to solve this, we would say that the inverse tangent of 4 is equal to x, and we would use our calculator, and then we would need to find out using the period to figure out when that happens. And remember that tangent is periodic by 1 pi rather than 2. And that's it for this section. Definitely check out all of the skills practice to see the types of questions you might encounter and how to solve them.